Hello friends, welcome to my channel. So in this session we are going to solve the given LPP using Simplex method for a minimization objective function. Okay, so in the last session I had solved one LPP for the maximization. So now we'll see how to solve the minimization problem using the Simplex method. So as you can see in the question, the objective function is minimize z equal to x1 minus 3x2 plus 2x3. Now the first objective is to convert this minimization into the maximization problem, and then we will convert the entire inequalities into the equality constraints. Okay, so we will rewrite the given problem in this way. So first we will convert this minimization into maximization. Okay, and to do that we write max z. Okay, max z equal to minus x1, so signs will get interchanged, plus 3x2 minus 2x3. Okay, and then converting this into the augmented form. So we have to convert the entire given problem into the augmented form. So what will be the augmented form? So that will be, so since we want RHS equal to 0, so it will be rewritten as the objective function will be z plus x1 minus 3x2 plus 2x3 equal to 0. This is subjected to constraints. Okay, so now we have to write the three different constraints. So what are the three different constraints we have? To convert that into equality constraints by introducing the slack variable, right? So we have to write 3x1 minus x2 plus 3x3 plus s1 equal to 7, and then minus 2x1 plus 4x2 plus s2 equal to 12, and finally minus 4x1 plus 3x2 plus 8x3 plus s3 equal to 10, and lastly we have to mention all the non-basic variables x1, x2, x3 and basic variables s1, s2, s3 should be always greater than or equal to 0. Now considering these values, we have to solve the simplex method using the tabular method. Okay, so now let us take all these basic and non-basic variables as the columnar values and we'll solve the problem. So now we have the first value will be x1 x1, then we have x2, x3, s1, s2, s3, then we have z, RHS and ratios. Okay, so what will be the value of x1 here? So let us all fill the values with all the constraints, and we have it here 3 minus 1, 3 1, right, 0 0 0, and this will become 7, and next value will be minus 2 4 0 0 1 0 0 12. Third constraint will be minus 4 3. Okay, and this is 8 0 0 1 0 and 10. Now we are going to write the objective function, that is x1 value is 1. Okay, and this is minus 3, this will become 2, and these 3 are 0 slack variables, that will be 1, and RHS is 0. Okay, done with the writing the table. Now we have to find which is the negative value here. Okay, here we are not getting the optimal solution because we can see that in the last row we have one negative value and rest are all positive. So considering the negative value as the entering variable, we have to encircle this entire column here, and we have to get the ratios for this. So to get the ratios, we have to divide the RHS value with the entering variable vectors. Okay, so that will be 7 by minus 1, that is minus 7, 12 by 4 is 3, 10 by 3 will give you around 3.33. So 7 minus 7 we cannot consider because it is a negative value. So out of 3 and 3.33, 3 is the least value and we'll consider it as the leaving vector. This is the entering vector, okay, and we'll round off the entire row. Okay, so we'll consider this one. So out of this, which is the intersecting value, that is 4. That is 4. Okay, we have to make this 4 as 1, minus 1 3, and minus 3 as 0. So to do that, as I already mentioned, you have to write the formulas. Okay, so for each row you have to write the formulas to make your job easier. I will just label all the rows with the name of the row numbers. Okay, the R1, this is R2, this is R3, and this will be R4. So now you can decide what is the formula for R2. R2 will be what? R2 will be R2 by 4. Okay, so if you divide this by 4, you will get the value of 4 as 1. Rest of the values has to be made 0. So what will you do? What is the formula for R1 now? R1 equal to, first you write R1, then you see the signs there, minus 1 it is there, so you make it as positive, plus 1 into R2, so R1 plus R2. Okay, similarly you just go for R3 and R4. What is the value of R3? You see, what will be the new formula for R3? R3 equal to R3, it is positive 3, so I will make it as minus 3 into R2, R3 minus 3R2, right? And for the R4 it is R4 minus 3 it is there, so I'll write plus 3 into R2. Okay, so these are the new formulas to get the optimal solution. Now let us consider these formulas and equate it in all the rows here, and we will get an improved solutions. Okay, so now first of all we'll fill the second row first. The second row has to be filled first. Okay, so this will become minus half, right? Minus half here, so minus 2 by 4, it will give you minus half, and this will become 4 will become 1, and these two values are always 0 because 0 divided by anything is 0, and then this will becomes 1 will become 1 by 4. This is again 0, here also 0. 12 divided by 4 is 3, guys. Yes sir. So we got the second row. Now we'll go for the first row. First row is R1 plus R2, so we have to consider the first row value R1, that is 3 minus 1 3 1 0 0 0 7, and that has to be added with minus half 1 0 0 1 by 4 0 0 3. Okay, and then we get the new values here. So here it will be 5 by 2, and this will become 0, this will become 3, this is 1, and this becomes 1 by 4, this becomes 0 0, and 7 plus 3 will give you 10, right? Similarly we will go for the R3 values. R3 will become here minus 5 by 2, this becomes 0 8 and 0, minus 3 by 4 1 0 and 1. Okay, and the last one R4, by applying that formula we get it as minus half here. Okay, and then we get 0 here, and we have 2 here, that remains same, and this we get it as 0. Here will be 3 by 4, this will become 0, this becomes 1, and this becomes 9, guys. Okay, so this is the second solution here, and we got the first iteration solution here, right? So in the first iteration solution we can see there is one negative value and then rest all are positive. That means we have not reached the optimal solution. We have to proceed further for the second iteration until we get all the values as the positive values. Okay, so now we are going for the second solution. So let us consider which is the negative value here. So based on that negative value we have to select. Okay, here minus half, so this will becomes the entering vector, right? So we have to select this entire column. Okay, and now let us divide 10 by 5 by 2. How much we get? Okay, that is 20 by 5, we will get it as 4, and 3 by minus half you will get it as minus 6, and 1 by minus 5 by 2 you will get it as minus 2 by 5. Okay, so negative values we cannot consider as the leaving vector, so we'll consider only 4 as the leaving vector. So we have to consider the first row, guys. Okay, so I'm considering the first row here. Okay, so I'm considering the first row, and then as you all know that we have to make this 5 by 2 is the intersecting value, right? So we have to make 5 by 2 as 1, minus half minus 5 by 2, and minus half as 0. Okay, so I'll rewrite the column numbers here. Okay, the row numbers, that is row 1, row 2, this will be row 3, and this will be row 4. Now we'll get a new set of formulas. Right now I hope you can write on your own. Okay, so what will be the formula for R1? So now we have to make that 5 by 2 as 1, right? So R1 will be R1 into 2 by 5. So R1 into 2 by 5, or you can write 2R1 by 5. So that will be your new formula for R1. Similarly for R2, it will be R2 plus, it is minus half now, so I am writing plus half into R1. Right, similarly what is the formula for R3? So what is the new formula you get it for R3? R3 will be R3 plus 5 by 2 into R1, and R4 will be R4 plus half into R1. Okay, so this is the new formula. Based on that we are going to solve it. Okay, now what will be the first value here? 5 by 2, right? We got 5 by 2, right? So that we have to make it as 1 here. Okay, so it will become 1, because we know that the formula of R1 is equal to 2R1 by 5. So this becomes 1, and this becomes 0. 3 becomes 6 by 5. This becomes 2 by 5. 1 becomes, and 1 by 4 will become 2 by 20. Okay, and 0 and 0 will become remain same. This will be 0 0, and last it will be 20 by 5, right? 10 into 2 by 5, 20 by 5. 20 by 5 you can write it as 4. Okay, and then we'll go for the second row. Second row formula we all know, R2 plus half into R1. So this should be 0 here, and this will come 1. This will become 3 by 5. This will become 1 by 5, right? You can calculate on your own. Okay, based on that formula. 3 by 10, this becomes 0 0 and 5. Okay, similarly the third row here, formula is R3 plus 5 by 2 into R1. So here after we apply we get 2 zeros here, and then will become 11. This will become 1, and then we get minus half, right? And 1 0 11. And the last row R4 equal to R4 plus half into R1, that becomes 0 0 13 by 5. Okay, 13 by 5, and this becomes 1 by 5. Here it will be 4 by 5. This becomes 0 1 and 11 itself. Okay, so that's all the steps we have covered here, and we can see it in the last row we have all the positive value. That means we have reached the optimal solution. Now it's time for us to understand what is the value of z, x1, x2 and x3. Okay, so since we have solved the problem using maximization, so we'll write max z equals, okay, max z equals, and we can see that in the last column, that's for z 0 0 0 as tall or 0, 1 is there only in one place, and that represents 11. So it is, the answer is max z equals 11 at x1 equal to, the first column is for x1. You can see there is only 1 1 and rest all are 0, so 1 is pointing to 4, so the x1 value is 4, right? And x2 value, we can see in the second column that we have 0 1 0 0, so the 1 is pointing to 5, so x2 value will become 5. And x3, we don't have zeros or 1, we have 6 by 5, 3 by 5, 11 and 13 by 5, right? So we do not have any answers for that, so x3 becomes 0. Okay, because the value should be either 0 or 1, so we, other than that we have all the other values, so x3 becomes 0. And this is the solution for you guys. And since the actual problem is of minimization type, so we have to convert that maximization into minimize. So when we convert that max z 11 into the minimization, we'll get the min z is equal to minus 11, and the value of x1 and x2 will remain same. So it will be at x1 equal to 4 and x2 equal to 5. Okay, So now we will just apply this solution to the substitute the values to the actual problem. So what is the actual problem here? What is the actual problem? We have the value of z, right? Min z is equal to x1 minus 3x2 plus 2x3. Okay, so what is the value of z here? Minus 11, right? So minus 11 equals, what is the value of x1? 4 minus 3 into 5, 4 minus 15. 4 minus 15 will give you minus 11. So LHS is minus 11 and RHS is also minus 11. That means that the values are right enough here, right? So the final optimal solution for minimization z is minus 11 at x1 equal to 4 and x2 equal to 5. Okay, so thank you so much for watching. If you have any queries regarding this problem, please drop your comments in the comment section below. Thank you so much.